Hi guys, welcome back to my channel Programming with Pirai. In previous video, we have seen about how to insert, how to delete and how to construct a linked list, right? Now, in this video, we are going to see a code implementation. If you haven't watched the previous video, I will give you in the description. Okay, fine. Now let's get started. See here, first of all, how to construct a linked list? We want to construct each node, right? So this is the code for construction of each node. See here, class node def init of self comma val is equal to -1, next is equal to none, which means I'm creating a constructor. Okay. Now inside that self dot val is equal to val and self dot next is equal to next. In previous video, I have clearly stated why I am putting this, right? Now class linked list, I am creating another class def convert. Inside this class, I'm going to do some of the functions I needed, right? First function is to convert an array into a linked list. How we can convert an array into a linked list? In previous video, I told you, right? Just see here. Let me explain this code in this video. See here, head is equal to none. So I'm just initializing head as none. Okay, there is no value. Now, if length of array is greater than 0, if the length of the array is greater than 0, then what should I do? That's the element present. So take the first element. Okay, let me take array as, just see here. Initially, this is the first element, right? Initially, this is the first element. Okay, take this element and create a new node. Okay, just see here, head is equal to node of ARR of 0. So I am creating a new node where the value is 1, and then what's the next? It is automatically set to none, right? And it is pointed as what? Head. Head. That's it. Next, current is equal to head. So current is pointing here. Now, sorry. Current is pointing this node value. Okay. Now, for I in range of 1 comma len of ARR. So we are going to check for these elements. Now, temp is equal to node of ARR of I. So initially, what is my I value? It is 9, right? So I am going to create a node whose value is 9 and next is none initially. Now, what will I do? See here, current dot next is equal to temp. So I am just removing this and modifying the address of this. Let me take address as 300. So I am modifying it. Can you understand this? So automatically a link is created here. Now current is equal to current dot next. I am just removing this current and moving this current here. All right. Now next step is for 7. So I am creating a node for 7. Now current is equal to current dot next. So let me take 7 addresses 400. So this will be replaced as what? 400. So link is between them. Then current is equal to current dot next. Now current will be here. Same procedure for 3. I am creating a node for 3, and then let me take node value as 500. Now this will be replaced as 500, and then current will become here. Same thing for 5. Can you understand this? Yes, and then current will be here. That's it. So successfully I converted array into a linked list, right? Now that's the one remaining step. What is the step? See here, at last I want to return what? The head. Why I am returning the head? You may ask. Why? Because see here, this is a starting point, right? By using this starting point of the linked list or else a starting node of the linked list, we are gonna traverse or we are gonna do some process, right? So this is so important. That's why we always keep track for this head. Okay. Now def display of self comma head. Now we are going to print the linked list so that I am going to implement this function. So what this function takes as an argument, it takes the argument as head. And one more thing, if you haven't seen about some oops concept in Python, just go and watch my previous playlist video where I give in the description. In that I clearly explain about what is meant by oops and what is meant by this variable, self variable. Here we can use any variables. Okay, so I clearly stated what is constructor and class, everything with addresses. Okay, now let's resume. See here, current is equal to head. Now initially current is where? At this point. Okay, current is at this point. Now if not head, let me take any other color. Okay, if not head, then what should I do? If there is no head present, I want to do what? Print empty linked list and return it. Why we are doing this? Because there is no node present, right? And then while current, there exists current. Yes, there exists current. See here, current has some value. Now print current dot val. So what is current dot val? It is 1. So 1 is printed. Now current is equal to current dot next. So current will be pointing now here. Okay, now value is 9, just print it. Again, move current. Now value is 7, print it, move current. Now value is 3, print it and move current. Now value is 5, print it, move current. Now it comes to where? Null, because at last the 5's address is null, right? None. So that it reaches the null. So this loop terminates. Can you understand this up to this? This is what the implementation of this linked list class. Now let's go move on to the next. See here, LL is equal to linked list, which means we are creating an object for this linked list class. Now get is equal to LL dot convert of some array. I have given some array. Now LL dot display of get. What is my answer? 19735. Can you understand this? Yes. Now the second thing is we are gonna see about how to insert at the beginning. Okay. So let me take the same linked list. What is a linked list? 19735. Now we are gonna insert a value at the start whose value is what? 3. So see here, I am creating a function called insert at start, and inside that argument I have given head and value. So I should call the function using what? Head and value, and then is equal to head, so that we are gonna get the head at the end of the function call, right? Come up with me, stay along with me, it will be more clear at last. See here, initially if not head, if there exists no head, then the creation of the new node should be my head, right? So what will I do? I will create a new node, okay, and I will assign it to the head, then I will return the head. That's it. That's it in a case of what? If there exists no head. But if there exist some values, some nodes like this, then what should I do? First of all, I want to create some node. Okay, here I have given this 3, right? So I will create a node called whose value is 3, and next is initially none. But in this time we know where should this temp point, right? Let me take this variable temp. So this temp should point where? This temp should point to this value, right? So this is my head, right? So I want to point to this head. So instead of none, I want to write head. That's why I have given here what? Head. Now can you understand why I am putting this head, right? Now head is equal to temp, right? Now this head will be modified to where? Here. Can you understand this? Now see here, first 3, then 1, then 9, then 7, then 3, then 5. That's what my answer, right? That's it. Yes. Okay, fine. So this is what the insertion at start. Okay, now it's time to see the insertion at the position. See here, in insertion at position, it is quite similar to the insertion start in one condition. Def insert of head comma position comma value. Now we are getting the head, position and value. Now if not head, then what should I do? Head is equal to node of val, then return the head. Same thing we have done in the insertion start. Okay, fine. Now current is equal to head, while current and position minus 1 is greater than 0. So here we have to take into the consideration. Now let me take the same node 1, 9, 7, 3, 5. Okay, same node. But in previous cell we added what? 3 at the start, right? So 3 will be at the starting point. Yes. So this is my node as of now till the execution. Now come up with me. If not head, if there is not head, no, we have head. So this condition will not get executed. Now current is equal to head. So current is pointing here. While current and position minus 1 is greater than 0. Why I am doing this? If I want to insert at this point, let me take, I want to insert at this point, then I have to reach this point, right? This point. If I want to insert at a, say example third position. At the third position, then I want to go for the second position, right? That's why position minus 1 is less than 0. I want to decrement the position by 111 by 111. So when I am dry running it, you will be understanding this. See here, current is equal to current dot next. Okay. Initially position value is what I have given here is 6, right? 6 and value is 10. In this problem, I have given 6 and 10, right? So initially current is here. Now current, we have current. Okay. What is my position value? Position is initially 6. So 6 minus 1 is 5. Whether 5 is greater than 0? Yes. So obviously I want to move this current here. Now current is pointing here. Let me take another color. Okay. Now current is pointing here. Now again, whether there is current? Yes. Now position is 5, right? We are doing minus 1 in this step. So 5. Whether 5 minus 1, 4 is greater than 0? Yes, it is greater than 0. So go on and move to current dot next. Okay, then position minus 1. So it becomes 4. Now again check whether there's current. Yes, 4 minus 1 is 3. 3 is greater than 0. Yes. Again move this current here and reduce my position by 3. Now again there's current and 3 minus 1 it is 2. 2 is greater than 0. So again move my current here and reduce my this 3. 2. 2 minus 1 is 1 and that is current. So again move here and make this value as what? 1. Now comes the twist. See here, there is current, but 1 minus 1 is 0. 0 is greater than 0. No. We should stop there, right? When I given the position as 6, see here, 0, 1, 2, 3, 4, 5, 6. So here should be my point, right? Here should be my node. That's why we are stopping at what? N minus 1 itself. That means position minus 1 itself. So I am stopped here. So here is my current. Now see here. If not current, if there is not current, which implies it is what? Invalid position. If there are, see here, 1, 2, 3, 4, 5, 6, 6 nodes, and I have given the position as 10. 10 doesn't even exist, right? In that time, this while current, this current will become what? None, and that loop gets terminated. In that time, we want to print what? Invalid position. In other time, we want to insert at a position, right? Now, temp is equal to node of val comma current dot next, which means, see here. So I want to create a node in which it points what? Temp. Okay. Now what is the value? Value is 10. Now what is its next? Its next should be what? This current dot next. This current points where? This current points to null. None, right? Obviously. So it becomes what? None. Okay. Now in next step, what should we do? We should do what? Temp dot next is equal, sorry, current dot next is equal to temp, which means just updating this link to where? Here. Can you understand this? Yes. Now return head. So some people might think why we are updating that temp dot next to current dot next. Instead of that, we can put current temp dot next as none, right? But when see this example 1, 2, 3, 4, and I have to insert 5 here. Let us think about it. Okay, I want to insert this 5 between this 2 and 3. Now what should I do? I should take this 2. This 2 is current initially. Just imagine this is temp. In this time I want to do what? Current dot next, which means 3. Okay, store in temp dot next, which means temp dot next is equal to current dot next, which means this 5 points to this 3. Yes. Now after pointing this, I want to remove and then I want to point current dot next to temp. This what I have done here. Now hope you would understand, right? It is simple. Fine. This for this reason I have used this statement, and at last I am returning the head. And while I am displaying it, what is my result? 3, 1, 9, 7, 3, 5, and 10. 10 is inserted. Can you understand this? So this is how we want to insert at the position. Now let us move on to next part, which is the insertion at end. Yes. Now, just see here. What is my node currently? It is 3, 1, 9, 7, 3, 5, 10, and then also, sorry, 10. We currently inserted 10 in the before, right? So, this is my linked list. Now, just observe carefully. If not head, then what should I do? Head is equal to node of value and return the head. This is what we have done in previous two steps. So in this time I don't explain this. Now current is equal to head. Current is pointing here. While current dot next, current is equal to current dot next. Why I'm doing this? Okay. In previous video itself I have told you, right, to delete the last, sorry, to insert at the last node. We want to be at last here, right? At the last node. That's why current dot next, which implies whose nodes next attribute hold none, that I should stop. This 10 holds what? A none, right? Because it is pointing to none. There is no other node step. So that while current dot next, which implies what? While current dot next is empty. Up to that I want to traverse. Okay, initially current is here, then here, then here, then here, then here, then here. At last it comes here, and now the loop terminates and the control flow comes here. Temp is equal to node of value. Okay, I'm creating a new node. Okay, inside this node I'm just, what is my value? In this program I have given the value as what? 10. Okay, so 10 will be my value. Now in next step, current dot next is equal to temp, which means here is my current pointer, right? So this current pointer link is updated to where? Here. So it is not no more pointing to the none. Okay, now it is fine. Now I want to return the head. I will return this head value, right? Now what is my output? 3, 1, 9, 7, 3, 5, 10, and then also 10. That's why my output is like this. Can you understand this? So this is how we want to write a code for insertion at the end. Okay, insertion at the end. Now we are going to see about deletion in the linked list. First of all, deletion as start. See here, if delete at start of head, we are getting a head as an argument. Now if not head, then what should we do? We don't want to do anything. Already there is no head, there is no node present. Then just leave it. Just return what? None. Now temp is equal to head. Just temp is pointing here. Now head is equal to head dot next, which means we are just shifting this head here. Now delete temp, which means just delete this whole object. Now return head. Now I am returning this set of linked list node. So what is my output? My output will be like 9735. Let me run it. Yes, can I understand this? Right. Now let us move on to the deletion at the node. Sorry, deletion as a position, right? So see this example. Now we have what are the elements we have? We have 9735. So this is my node. Fine. Now let me change the value of deletion as 2. Okay. Now if not head, I just want to return none, or I can also return head. There is no problems because already head is none. Returning head or none is absolutely fine. So that's why I used head here. Okay, now if position is equal to 0, if position is equal to 0, then I should do the stuff that I have done for where at the start. I done some stuff on the start, right? Deletion at the start, that I should do here. Else I want to do what? Current is equal to head. So current is finding here. Now while current, yes, current and position minus 1 is greater than 0, which means as similar to insertion. If I want to delete this 3, then I should stand here. Then I want to connect this 7 with this 5, and I want to delete this 3. That's what we want to do in deletion. So if I want to delete, let's say this 0, 1, 2, if I want to delete this 2, then where should I stand? I should stand at the index called 1. So that's what I am trying to say it. Okay, so we are going to do that. Now see here, let us take position as 2. Now whether that is current, yes. 2 minus 1, it is 1. 1 is greater than 0, yes. Okay, now current is equal to current dot next and position minus 1. So move this current here. Now make my position as what? 1. Wait, now again, that is current, yes, but position minus 1 is what? 0. 0 is greater than 0, right? Obviously it is false, so that this condition will terminate. Now if not current or not current dot next, which means if I am at a position where like this and I am standing here, let us assume I am standing here. Now we can delete this too, but in a case I am standing here, whether I want to delete any other elements back then, no, right? And in worst scenario I am standing here, already there is no node, then how can I delete a node which is to the right of me? Yes, so that these are the edge case we want to find. Now print invalid position and return the head. So this condition is programmed to overcome this error. So see here, now temp is pointing to where? This node, current dot next. So temp is pointing here. Now current dot next is equal to temp dot next. So automatically this link will be updated to where? To here. Can I understand this? Yes. Now delete temp. So this temp gets deleted. Now what is my remaining linked list? It is 9, 7 and then 5. This 3 gets deleted, right? So 9, 7 and 5. So let me run it. Yes. 9, 7 and 5, right? Now at the last, deletion at end. Okay, how to delete a node at the end? So see here, first of all, what are the elements present now? So 9, 7, 5. These are the node value that are present as of now. Fine. Now if not head, then return. If not head dot next, delete head and return none. Which means this see here, if there exists only 9 and head is here, this implies head is the last node. But how can we find it? It points to where? None. There is no next address. So I want to delete it. That's why delete head and return none. Can I understand this? And then if this is not the case, then what should I do? Current is equal to head. So current will be pointing here. Now while current dot next, which means where should I stop to delete the last node? Where should I stop? I should stop at this node, right? If I stop at this node, I can connect this link to none, right? And then I can delete this node. So I should stop here. That's why I'm using what? Current dot next, which means current dot next means this 5. 5 dot next means none. So up to current dot next is not equal to none, I want to traverse one by one. Okay. First time current is here, and then in next time current will be standing here. Up to this clear? Now temp is equal to current dot next. So temp. So let me take this as temp. Okay. Initially current is here. So current dot next is actually this of the node. So it is temp. Now current dot next is equal to none. So this current dot next. This is what? Updated as none, because here is absolutely none. Then why should I update like temp dot next? I just update this as none. So this link is what? Modified as none. Yes. Now delete temp. So this object gets deleted, right? And then return head. Now what is my head? It is pointed to this 9. So it is returned. So what is my answer? It is 9 and 7. Can you understand this? Yes. So let me submit it so that it will be more clear. Yes, 9 and 7. Can I understand? So in this video, we have seen about a code implementation for insertion as start, end and position, deletion as start, end and position, and construction of linked list from the array, and then how to create a node and how to display the linked list. So these all are about the singly linked list. In next video, we can see the implementation of doubly linked list and the code implementation of doubly linked list. Thank you.